Hey class, Mr. Houston here, back with Chapter 7. We are jumping into more triangles. Chapter 7 is all about right triangles, excuse me, and right triangles in trigonometry. We're going to be learning more and more about triangles and what we can apply to them, particularly in this case, right triangles. Today we're going to start off with something that should hopefully be memorable that you have learned before, and that is the Pythagorean theorem. You should hopefully remember that the Pythagorean theorem is just a squared plus b squared equals c squared. A couple things about this right triangle is remember that the side opposite the right angle is known as the hypotenuse, and that the two other sides are known as legs. Okay? So the square of the legs, the sum of the square of the legs is equal to the square of the hypotenuse. Okay, so we're just going to put that into operation today as we work through our examples. So example number 1, find the length of the hypotenuse. So again, remember, we have a squared plus b squared equals c squared. Okay, if we go across from the right angle, that is our hypotenuse. So we are going to say that 8 squared plus 6 squared equals, in this case they call it x squared, that's fine. 8 squared is 64. 6 squared is 36. Okay, add those two together, we get 100 equal to x squared. We want to know just what x is. So in order to figure that out, we have to do what's called square rooting both sides, which basically means we're trying to find the factor that multiplied by itself will give us 100. Hopefully you remember that the square root of 100 is 10. So in this case, this is known as 10. Okay? Just a little side note here. 6, 8, and 10 are what's known as a Pythagorean triple. Basically means that the legs and the hypotenuse are all whole numbers. We're not going to get into those too much, but just want you to understand that anytime you have whole number answers as your legs and your hypotenuse, that's known as a Pythagorean triple. Okay? Alright, so what I believe will be the biggest application of Pythagorean theorem is a question like example 2. And that's probably why they call it standardized test practice. So you have a 16-foot ladder that rests against the side of a house, and the base of the ladder is 4 feet away. Approximately how high above the ground is the top of the ladder? So as you can see, a practical application, we have that 16-foot ladder. It's leaning up against the house. It's 4 feet away from the house. We want to know how far up the house it is. Okay, so just a few things to look at here. Again, going across from the right angle here, that is our hypotenuse. So again, we have a squared plus b squared equals c squared. We know c squared, or we know c is 16, and we know one of the legs is 4. Now it doesn't matter which one you choose to use. I would say you do b squared, and you'll see why here in a second. So that would be 4. So we're trying to find, and I guess technically they call it x, so we'll call it x. So x squared plus 4 squared equals 16. So x squared plus 16 is equal to 256. Now again, the reason I chose to put 4 at b is so I could subtract 16 from both sides. I'll get x squared equal to 240. And again, to find, to figure out something when it is squared, to simplify that down, we take the square root of it, and in this case that'll leave us x, and the square root of 240 is 15.49, so the ladder is approximately 15.49 feet up on the house, and that would be closely approximated to letter D. Now if you notice, just to point this out for standardized test practicing, they put a lot of numbers in here that are very familiar. 240, we noticed that was over here, 240. 20 feet. 20 feet is if you would just add these two together. So you get 20. Not sure where you'd get 16.5 feet from, but then they have your answer. So notice that in standardized test practicing, especially for multiple choice, they are going to try and figure out, or try and find ways to put numbers in there that are actually part of the problem. Okay? All right, so let's do some more application to this. So they want you to find the area of this isosceles triangle. If you remember, area of a triangle is base times height divided by 2. Well, if you notice here, we have the base. Unfortunately, we do not have the height. Okay, so we need to figure out h first. All right, so in order to do that, we're going to do a squared plus b squared equals c squared. Pick either side. It's an isosceles triangle, so it is the same. Just notice that, hey, we are across from the right angle there, so 13 is our c. So we have 13 squared here. Again, 5, it doesn't matter where you put it. I'm going to put it as b. And so we are trying to figure out h. So h squared plus 25 is equal to, 13 squared is equal to 169. We'll subtract 25 on both sides. We'll get h squared equal to 144. Square root, h is equal to 12. So if you notice here, 5, 12, and 13, again, are a Pythagorean triple. I'm not expecting you to remember Pythagorean triples, just understand that when you see whole number answers, that those are Pythagorean triples. So now we can find the area of this triangle. Biggest thing you'll get tripped up on here is making sure that you understand the base is actually 10. So this is going to be 10 times 12 divided by 2. So area is 120 divided by 2. So the area of this triangle is 60 meters squared. Okay, so again, they're throwing a Pythagorean theorem to help you figure out the area of that triangle. And last but not least, we'll wrap up on a pretty easy one. They want you to find the length of the hypotenuse again. Okay, even if they didn't tell you to find the hypotenuse, remember that it's across from the right angle. So a squared plus b squared equals c squared. Doesn't matter which way you put them. 24 squared plus 10 squared equals c squared. 24 squared is 576 plus 100 equals c squared. So this is 676. Again, square root both sides. The square root of 676 is 26. Again, a Pythagorean triple. Okay? So hopefully you just remember that this is how the Pythagorean theorem works, and that we're going to get nice and cozy with right triangles throughout this chapter. If you have any questions, bring them with you to class, and we'll see you then.